Okay, so section 5.1, graphing sine and cos function. So this is where I said that we're taking the unit circle and we're like pulling it apart and laying it flat, and then we're going to draw graphs based on that. So we're going to draw sine, cos, and tan graphs. Okay, so the important things on the top of your notes is they call it period length is like a cycle. It's like in physics, you would see it where something repeats itself. So it could be like a heart monitor, you know, where you see it go, the bleeps, and then it'll repeat the bleeps. Those are the cycles or the period length, the same as it would be as it is in sine and cos. You can find the period length by going 2 pi over b, and we'll talk about what b is, or 360 over b, because 2 pi and 360 are the same. One's in radians, one's in degrees. And then the amplitude means how high your graph's going to go up and how low it's going to go. Okay, so it's like your maximum value, subtract your minimum, divided by 2. You're finding the average between your max and your min. Okay, and when we're talking amplitude, we always talk positive. Okay, you're not going to say you have a -2 amp. Okay, you would say you have an amp of 2, and if it's a negative, that just means your picture is going to open upside down. Okay. So if we want to look at what a rough sine graph looks like, here's as simple as it can get. Okay, this is before there's any amps or anything included in there. So we can even write it like this. Okay, so this piece will be our amplitude, and this piece will be our part of our period length, because remember I said period length is 2 pi over b. Yeah. Well, it's kind of just with the notes with it, yeah. So period length is 2 pi over whatever b is. Okay, so in this situation, we don't have anything in front of sine, so it's assumed it's 1, and we don't have anything in front of the x, so you assume it's 1 also. Okay, so in that situation, so this is example 1. In this situation, our amp would be 1 because that's what's in front of sine. And our period length is going to be 2 pi over 1, which is just 2 pi. Okay. Okay, and a sine graph basically makes 4 movements. Okay, so it's important when we mark our amplitude, it's 1 and -1. That means it's going to go as high as 1 and it's going to go as low as -1. And then it's going to make 4 movements. Okay, so we said that our period length is 2 pi, so that's where our picture's gonna end, because we'll draw one cycle and then it could make another cycle and another, keep going like a heart monitor, but we'll just draw one. Okay, so for sine graphs you always start at the origin and you put a dot. At your next mark you're going to be up at your amplitude. Okay, then you go back to the x-axis. Your third mark is down to your minimum value, like how far you go down, and then you end it off at your period length. Okay, and then the cycle will repeat. Okay, so your picture is going to look like this for a sine graph. Okay, and we want to fill in the rest of these ticks so that we know. So if this is 2 pi and there's 4 ticks, we got to split 2 pi into 4 pieces, basically. So halfway would be 1 pi, right? And halfway between 0 and a pi is a half a pi. So you're going to half a pi, pi. 1.5 pi, 2 pi. Okay, so all we did was split that 2 pi into 4 pieces. Okay, so if you were to continue on, your picture would look like this. Whoop, sorry. And then it would come back and it would just keep going like that. Okay, the difference with a cos graph, and I know it doesn't show that we need to talk about that right now, but in example 3 we'll be talking about it, so I just want to mention it right now. A cos one works the same way, except, so this is the amp. Oh, I could have put a B in here. The period, so I'll say the PL, period length, is still 2 pi over B. Okay, so that all still works the same. The only difference with a cos graph is you start at the amplitude instead of the origin. So here we started at the origin. If we were doing a cos graph and our amp was 1, you'd start at your amplitude. And then you'd go down, under, back, and up. So your picture would look like that. Okay, so you're starting high instead of starting on the origin. Okay, so that was example 1. This, yeah, period length is 2 pi over B. Okay, so example 2 says, any function of the form a f of x is related to y f of x by the vertical stretch of... Okay, so that's a lot of craziness they're talking about. All they're talking about is the amplitude, which we talked about already. Okay, so we were saying that in front of your sign, because remember, if we think about these things as transformations, whatever was in front of our equation was a stretch, right? Vertically. So that's the same, it still applies here. And if we had a negative in front, then that would be a reflection. So your picture would start underneath first. Okay, so if you're thinking of it still as transformations, this is like a stretch. But we call it the amplitude when we're talking about these graphs. Okay, so even if, for example, I think these are the ones we're talking about in the example, 3 sine x, then we're going to graph 0.5 sine x, and when y equals minus 2 sine x. Okay, so in these situations, this first one, the amp is 3. This one, the amp is 0.5. And in this one, the amp is 2. You don't say negative 2 because your amp is always positive. The negative just means our picture's going to reflect underneath instead. Okay? So if we were to draw these out, remember there's always 4 movements. And this first one, our amp is 3, so we're actually going as high as 3 and as low as negative 3. Okay, so for our first one, maybe I better get some different colors going here. This is the red one I'm talking about. So we start at the origin, we go up to 3, back to our x-axis, down to negative 3, and end at our period length. Our period length being 2 pi. Okay. If we're talking about this one, 0.5 is our amplitude. So we're only going up to a half every time. So again, we start here, but we go to a half, back to the x-axis, then down to a half, and then back. So my picture's off a little bit, but it would be half as much. And if we're talking about the negative 2, it's just meaning we're going up 2 and down 2, but we're going to start as a reflection. So we're, instead of going up high first, we're going to go down low. Okay, so if 2 is here, again, we're starting at the origin, but instead of going up, we're going down 2 first, then back to the x-axis, then up to 2, and then back to the period length. So our picture looks like this. Okay, does everybody see the difference with that? It's just a reflection of what the normal one looks like. Okay, so for example 3, it says they want us to sketch a graph of y equals... Oh, I'm still in green. Sorry. Let's start. Okay, so we want y equals sine 4x. So what we're focusing on in example 3 is the period length now. Okay, so here, in front of here, our amp would just be what in this situation? 1, yeah. Okay, and so what we're focusing on is our period length. So I told you our period length is always, oh, here we go, 2 pi over whatever b is. And our b in this situation is 4. So it's going to be 2 pi over 4, which is pi a half. Okay, so that's going to be our period length this time. So everything's still going to work the same. Okay, but instead of ending at 2 pi, it's going to end at a half. Okay, so we need to split a half into 4 pieces. So how do you split a half into 4s? You split it into 8. Right, so you'd go pi over 8, 2 pi over 8, which is like 1/4, 3 pi over 8, and then 4 pi over 8 is a half. Okay? And then our amp is 1 and -1. So if we were to draw this, all you do is the same. Start at the origin, up, back to the x, down below, and end at your period length. Yeah, I always make them, like, technically we compressed him, right? Because we made him half as long. But all you have to do is change the axis or whatever you're going up by, and then the picture looks the same. Okay, but it's actually ending half as far, right? Because usually it, well, a quarter of the way. It usually ended at 2 pi. Okay, and in a situation, it's saying from 0 to 360. So technically, these should be in degrees if we were doing it right. So half a pi is 90 degrees, right? And then you would go back on what an eighth is in degrees. You can look at your unit circle. What's that? Yeah, 90 into 4 pieces too. This one would be 45. And then you'd have to split 45 in half. Okay, so then the second part of this was they wanted you to see what this would look like. Okay, well in this situation our amp is still 1 and our period length is 2 pi over a half. Okay, so 2 pi over a half is a fraction over a fraction. So it's really, if we multiply by 2 over 1, and 2 over 1, you have 2 pi times 2. So your period length is actually 4. Okay, so our picture would just look like 1, 2, 3, 4. It's going by pi's. 1 pi, 2 pi, 3 pi, 4 pi. Oh, I did. We go here, up, back, down, here. So it would look like that. Okay, our last example is a cos one, which we talked about earlier, so nothing really different. Okay, this is still our amp. Our period length is still 2 pi over whatever b is. It's just, we draw it by starting at the amplitude. So in this question we have y is equal to minus 3 cos 2x. Okay, so what's our amp in this situation? Yeah, it's 3. We're going to have a reflection, so I don't know if you just want to make a note so you remember and just say reflection. Okay, because we're going to start opposite instead. Yeah, since the amp is a negative, or a negative's in front of the amp, we'll say. Okay, and then our period length is going to be 2 pi over b, and our b is 2. So 2 pi over 2 is just pi. Okay? So when we're drawing this, our amp is 3, and -3, we go down. So remember, it's cos, so you start at your amp, but it's also a reflection, so we're going to start at the negative amp, or like the reflection piece of it. So we're starting here, right? And we're still splitting this into 4 chunks, the period length being pi at the end. Okay, so we're just splitting our pi into 4 pieces. So we're doing quarters. 1/4, 2/4 is a half, 3/4, and then 1 full pi. Okay, so our picture will start at the lower amp, and then we go up to the x-axis. We go up to the highest maximum point, back to the x-axis, and then down to the period length there. So we go up, around, and that's what our cos picture would look like.